Hi class. So as I told you, I wanted to make a video showing you solutions from the linear modeling homework number 1 and 2, so that way you could learn from those and hopefully have a better product for for your linear modeling project. So as I mentioned, some of you did pretty well on this, and some of you not so much. I know some of you had some real difficulties finding the equation of a line, given 2 points or given the line. So hopefully this will help you practice that skill as well, right? I mean, the big part of the class that you should get out of is definitely like using linear functions. All right. So on the right side, I have the linear modeling homework number 1, and we'll work through all of these or a number of these. It can some of them become pretty repetitive, and I did that to give you practice, right? So, like number 1, we're given a scatter plot. We're told that we have the number of CDs in millions that were sold between these years, 1999 and 2005. And what we're saying is, assuming that this trend continues, we want to estimate for how many we would expect in 2006, right? So if I look at my scatter diagram, right, each tick mark along the x-axis here is 1 year. So we need to estimate for this last tick mark, right, at the very edge. So the best way to do this would be to draw a line of best fit, right? So I'm going to use insert a shape of a line to do this well on the computer, but you should use maybe a ruler, or in one of the videos I recommend that you watch, he used a piece of spaghetti, right? So you can use a piece of dry spaghetti, and the benefit to that is you can see on both sides then of your scatter diagram. And remember, you're trying to place a line that represents all of your data, right? And you want to eliminate the amount of space from any point to the line, or a distance from the point to the line, right? You want to try to minimize that. So you're kind of shooting more towards the center, right, of all your data, right, in a sense. Right, so maybe something like this line seems to fit my data pretty well, right? So then we're using this to estimate for the point 2006, right? And it looks like it hits right about 650, right? So for number 1, let me grab some ink here, right? So for number 1, you should have something about around 650 million CDs, right? Sold in 2006. Right, that's what we're estimating. All right. So then number 2, so you're told the table below shows the predicted annual cost for a middle income family to raise a child from birth until adulthood. Draw a scatter plot and describe what relationship exists with the data. Right, so we want to take these points, right? So I'm just gonna copy the table here on the left, so that way I can reference it, right? So this is for number 2. Right, and then we also want to talk about the relationship. Right, so here on the next page I gave you an item that you can use, and I can't draw on the on the Microsoft Word. I can't draw on that, so I'm just gonna paste the image over here so that way I can draw the points for you guys. Right, so I'll use red ink to plot the points. So one point we have is 3, and notice along the y's, my units is in the thousands, right? So we have 3, and then we would want to plot like 10.7, right? So maybe around here. And then we have 6 years old, and then somewhere around 11.7, right? Will be here. And then we have age 9, and our data tells us about 12.6. And then for 12, we have 15,000, so we'd want to plot at 15. Oops. And then for age 15, we have 16.7. Right, so there's my scatter diagram, right? That's what we were asked to do. Draw a scatter plot, and then we're asked to describe the relationship, right? So for the relationship, you could say, that our data has a, we could say, increasing linear relationship. Right? You could say something like that. Or we have a positive, positive correlated data, right? That a linear, how about positive linear correlated data, right? Something to that effect. So all that's meaning is that if I were to draw my line of best fit, right, I'm going to have positive slope, right? Or we call that an increasing function, right? So my data seems to be, my y value seems to be increasing as x is increasing, right? So we got number 2 done, and then we'll look at number 3. So number 3, you're asked to make a scatter plot of the data in the table, draw a line of best fit, and then what is the equation of this line of best fit, right? So we can certainly do that. So again, let me just grab and paste these parts into my OneNote file. Right, so I'll plot these points really quick. Right, so I'll plot them in red again. So we have the point negative 2, 2, right? So here, and then we have negative 2, 3, negative 1, 2, 0, 1, 1, 0, 1, 1, 1, negative 1, 2, negative 1, 2, negative 2, and then 3, negative 2. Right? So I'm pretty sure I grabbed all those, right? And then we're asked to draw a line of best fit, right? So let me use the line tool. That way I make sure I get a straight line. So I might pick a line that looks something like this. Right? And then notice that, so to find an equation of a line, I need 2 points, right? So it looks like this point is on my line, and also this point is on my line, right? So it just so happens that some of my data points are falling on this line of best fit, but that doesn't have to be true, right? So if that's not true, you still want to find areas where tick marks cross, right? If at all possible. So like here. So what that does, that's just going to eliminate the amount of guessing involved, right? So to find the equation of this line, right, what we know is that I have a line that goes through the points, negative 2, 3, and negative 1, 2. Right, we want to come up with the equation for this line. So the first thing we need to do is find slope, right? So slope is change in y over change in x, right? So in this case, my slope would be 2 minus 3 all over -1 minus -2, right? So that would be -1 all over, let's see, we'd have -1 plus 2, so that would be +1, so we get -1, right? So I have a -1 slope, so then we could use point slope form, right? Y minus y1 equals m times x minus x1. We could plug in a point with my slope and come up with the equation of the line, right? So I'll use this second point, right, to plug in. So we'd have y minus 2 equals, our slope was -1 times x minus, so this would be minus -1 or +1, right? So then we would need to distribute here. So I get y minus 2 equals -x minus 1, and then add 2 to both sides, and I'm left with y equals -x plus 1, right? So this is the equation of this red line, right? And this is my line of best fit. Right, we can also call this the linear trend line, right? Oops. It's also called a regression line. Right, so there's different terms for this line for when we're doing linear modeling, but those are the three that you'll typically see, right? Line of best fit, linear trend line, or sometimes just trend line, and it's also a regression line. Right? And typically there's there's some more advanced techniques that we can use to find this line, but for this part, this homework, right, kind of the big picture I wanted you to see is just the most basic way to come up with a linear trend line, and that's just to kind of eyeball it and draw it in, just to build you an understanding of what it is. And then in the next homework, we're focusing more on the technology and applying it, and you're going to use Excel to calculate this linear trend line for you, right? All right. So how many we have left here? 4, 5, 6, 7. All right. So we got about halfway done, maybe. Right. So we did number 3. So on number 4, you're told that the table at the right gives the number of hours spent studying for a science exam and the final exam grade, right? So my input variable is the amount of hours we study, and my output is the grade from the final exam. So we're asked to draw a scatter plot and draw in a line of best fit again, right? So it's very similar to what we did in the last one. Right, so we have number 4. Again, I'll just copy and paste this over for ease. All right, so my study hours are all integers, right? Going from 0 up to 5, right? So along the x-axis, I would just label these, 0, 1, 2, 3, 4, 5, 6, 7, right? So these are my study hours. Then along here, right, is the grade, the final exam grade. Let's see, my lowest final exam grade is 60, right? There's my min, and my max here looks to be 92. Right, so there's my min, and there's my max. So we already provided this, and hopefully everyone knows this is called a line break here, right? So what that line break tells us is we skipped over some data, right? So when you have a A graph, you need to have a constant interval, right? So like if you go 0, 5, 10, so forth, you need to keep going up by 5s, right? But what the line break allows us to do is skip over some initial values where there would have been just some white space, right? So it makes our graph more efficient. And this marker is important to tell the reader that, right? So that way it makes it obvious for what we did, right? Because we don't want it to be deceitful. So I'd probably start at 60, and then we need to go up to 100. So if we go 60, we have what? We go 65, 70, 75, 80, 85, 90, 95, 100, right? So I'll just go up by 5s. We have enough room for that, right? So 60, and then I'm just going to label every other one, right? So 70, and then we have 75, 80, 85, 90, 95, 100, right? So we're going up by 5s while I'm just labeling every other one, right? So we need to plot these points, right? And again, I'll do this in red. So we have 3 hours and 84. So that would be about here. And then 277. So that'd be like here. 592. So it would be about here. 170. Right, would be here. 060. Right, would be here. 490. Be here. And 375 would be here, right? So that appears to be my data, right? So then we're also asked to draw in a line of best fit, right? So let me grab my line tool again, and I might draw on a line, I don't know, something like this maybe. Right? So notice my line, I have kind of shifted shifted here because most of my data is up in this range, right? Where only two data points are kind of below this type of trend if we draw a straight line through these points. So that's the trend line that I'll come up with, right? So again, you might have a little different trend line. The big idea is, that your line isn't completely like off the wall different, right? So I'd probably use this point and this point to create my equation of a line, right? And again, the reason why I chose these two specific points is there's no guessing involved for what their x and y values are, right? They appear to be exactly on where our markers are, our tick marks. So the first point looks to be what, 2, 75, and then this point here lines up with 595. Right? So the first thing I need to do is find my slope. So we'd have 95 minus 75 all over 5 minus 2. Right? This gives me slope equals, so 95 minus 75 is what, 20? And then 5 minus 2 is 3. Right? Let me grab something real quick. Right, so then now that we have slope, we need to get an equation of a line, right? So remember, whenever you're trying to find a linear equation, we need a starting point and we need slope, right? So I would use slope-intercept form, or not slope-intercept form, but point-slope form, right? I think it's easier in this case, but you can use slope-intercept form if you wish, right? So point-slope form is y minus y1, right, equals m times x minus x1. So if I plug in slope in one point, so I'll plug in the point 2-75, then we can get an equation, right, and put it in slope-intercept form. So I'd have y minus 75 equals my slope 20/3 times x minus, and then x1 would be what, 2. Right, so the first thing I want to do is distribute the 23rd, so I'd have y minus 75 equals 23rds x, and then 23rds times negative 2 would be minus, what, 40thirds? And then we would add 75 to both sides. Right, so we'd have y equals 23rds x. And then we can add these up, right? So take negative 40thirds, add that to 75, right? I get 185 thirds. Right, so here's my equation. And if you prefer, we could turn these into mixed numbers, right? So 23rds is what, 6 2/3? And 185 thirds is 61 2/3. Right, so we can kind of use this line to see if it makes sense, right? So this slope makes sense, right? It's a positive slope for 1, and my line, or my equation is increasing, right? And what it's saying is for every 3 hours I increase, right, I'm predicting that I'll go up 20 percentage points in my exam score. And then here on the right, I have 185 over thirds. This is my score if I study 0 points on the test, right? So 61 2/3 appears to be, close to here, right? Which is where my my x-intercept, or my y-intercept is located. Right, so that equation is reasonable. So that's part B, right? So part B is here. Right, so I guess starting here, we started part B. So then now, part C, we're asked to predict the grade for a student who studied 6 hours, right? So in other words, x is 6, what's y? Right, that's what we're trying to find. So if I plug in 6 in for x, we can certainly solve for that, right, using my previous equation. So I'd have y equals 23rds times 6 plus 185 thirds. Right? So 23rds times 6 would be, what, 40. And then we're adding 185 thirds to this. So 185 thirds plus 40 is 305 thirds. Or what would be 101 and what would be 101 2/3, right? So this is the y value we're predicting. So we're predicting that somebody who studies 6 hours would get over 100% on the exam, right? Which doesn't, could be realistic if there was like a bonus question on the exam, right? But this could be not realistic if there were no bonus, right? If 100 was truly the maximum score you could get on the test, right? So then part D says, could this line go on forever? Why or why not, right? So for part D, we would say no, right? No, this line cannot truly go on forever. Right, and the reasoning behind this, so if we look back up my scatter plot, so this line is going to keep rising, right? It's going to keep going in the upward direction forever. And certainly there is a cap, there is a max on the score that someone could receive on an exam, right? You can't get like 1,000,000% or can't keep getting bigger and bigger and bigger. There's going to be some cap, right? It could be bigger than 100%. So maybe there was 10 percentage points extra credit on the exam, then the maximum score you could get would be 110%, right? So there's definitely going to be some max. So this line, it cannot keep going on forever, right? But this line can help us, help us see what's going on in the data and make some predictions, right? And obviously, this isn't going to be true for everyone, right? So statistics, isn't like the gospel. Like it's not going to be exactly correct, right? We're just basing this off observations, right? So in this case, so each data point is an observation, and we're seeing this linear trend. So as students increase their study hours, they're increasing their exam score, right? Which makes sense, right, in the data, right? So the more you study, the more potentially you can increase your exam score, right? The more comfortable you are with the material, right? So we would say, no, this line can truly not go on forever, and we would say, you could say something like, there will be a maximum test score that you cannot go above, right? And then also we could start to think about the x values also, right? So far I only talked about cap being on the y, but also this line is going in an upward direction, which means it's going up forever and to the right forever, right? So eventually this will cover all x values, right? But also there is going to be some cap on how many hours someone can spend studying for this particular exam, right? We could find a realistic cap for study hours, but also you could even think about, how many days from day one until the final exam of the term. And you could take those number of days and multiply by 24, and that would definitely be a maximum that the number of hours someone could spend studying for a particular exam for a course, right? And that would probably be a lot higher than like the realistic maximum of study hours, right? Because I doubt someone's going to study 24 hours a day with no breaks from day one till the finals, right? That's just not practical, not realistic. But that would definitely just be an easy way to find, I guess, like an overestimated max, right? So we could try to get down in smaller windows, right? But you'd have to make some assumptions to do that. But certainly we can, just from that simple example, we can conclude that there is also going to be a max for the x values, right? So that could be another argument for why the line could not go on forever, right? So you could also talk about the x values, right? Right, so you could say also there will be a max reached for the amount of hours that someone can study for the final exam. Right? Good. So hopefully that makes sense to you, right? So number 5 has to do with baseball ticket prices, right? So that's kind of cool. In fact, I was just at baseball field all day. My oldest son is on 2 different baseball teams. He's on playing like a rec league for Guyan City, and then also on a travel league baseball club. So we're doing baseball every day. Right. All right. So number 5 again does with baseball ticket prices. We're given a scatter plot. We're already given like a trend line also. In part A, we're given 2 particular points to use to find the equation of the trend line, right? It says place your final answer in slope-intercept form and show all calculations, right? All right, cool. So again, we're starting off with 2 points, right? Just like we've done all along in this example so far, right? And then we have 2002, 18.75, right? So when you're given 2 points, you want to find the equation. First thing you always need to do is find the slope, right? Change in y over change in x, right? Should be pros at this by now, right? Finding slope of a line. So we would take 18.75 minus 17.6 all over 2002 minus 2001, right? So 2002 minus 2001 is 1, right? And then 18.75 minus 17.6, we get what? 1.15, right? 1.15. So 1.15 divided by 1, of course, would just be 1 and 1500ths, right? 1.15. So that's my slope, right? So we're getting the equation of a line, right? So I would want to do point slope form. So y minus y1 equals m times x minus x1. Then we can plug in 1 point with the slope to find the equation of a line. So I'm just going to plug the first one in, right? So I'd have y minus 17.6 equals my slope 1.15 times x minus x1, which is 2001. So we'd have y minus 17.6 equals 1.15x minus, so take 1.15 times 2001, and I get 2301.15, right? So then we would add 17.6 to both sides. So I get y equals 1.15x. So take our previous answer and add 17.6 to it. So I would get minus 2,283.55. Right, that's what I get. So this is my equation in slope-intercept form, right? Remember, slope-intercept form is y equals mx plus b, right? All right. All right, good. All right, so moving along here. Part B says interpret your slope in part A in real world terms. Right? Excuse me, can't talk, I guess. So this was part A, and part B is I want to take my slope m equals we found it to be 1.15 and put it in real world terms, right? So I think the easiest way to do this is think about this way. So 1.15, my slope, remember, is change in y over change in x. So we can think of this as 1.15 over 1, right? And the units for my y variable, right, if we scroll up here, my units for the y is the average price in dollars, right? So it's important for the unit. And then down here, my change in x is in years, right? And my whole data is on baseball ticket prices, right? Baseball ticket prices. So what I like to do is I like to use kind of this generic sentence, if you will, for interpreting real-world terms. This seems to help students a lot, and I posted this on Canvas, right, as an announcement. I think maybe like 4 or 5 days ago I did this. So the generic sentence was the and then you put here output. So the output is changing by, and then here we'd put slope, and then y units per, and then here you'd put x units. Right? So I'll highlight the areas that we need to fill in, right? So we need to fill in where it says where it's in green. So we would start the sentence by saying so I would say the average baseball ticket prices are changing, right? So I changed is to are just for our sentence structure, right? So the average baseball ticket prices are changing by, and then my slope is 1.15. So we can even put this in dollars, right? So by $1.15. So that's my y unit, my y units, and then per, and then my x units are years, right? So per year, right? So that's how we can interpret this slope, right? So we're saying the average baseball ticket prices are changing by $1.15 per year, right? So we can assume that if we increase by a year, my ticket price will go up around $1.15, right? Based on our linear model. Right, good. So there's part B. So then part C says use your equation to tell the price of a ticket in 2009. And then you're asked, is this an extrapolation or interpolation, right? So remember that the difference between interpolation and extrapolation. So I want to start with that first, right? Because that seems to be more difficult for students, right? So if you notice, my lowest data point is here, 1997, right? And then the last data point I have is for 2006, right? So that's kind of, inside this green, these are where my data points follow, right? They fall in between these green bars. So anything inside of here is called an interpolation, right? So interpolation. And then anything on the outside, right? So it can be after here or before over here. This is called extrapolation. Right, so then here we have extrapolation. Right. So in this case, we're asked to estimate for 2009, right? So I know if I'm estimating for 2009, that's going to be outside of my data range, right? Because we'd have 07 and then 08, and then we're trying to find 09, right? What would this y value be for 09, right? Is what we're trying to figure out, and we're going to use our linear trend line here to estimate this, right? To find what this expected value would be, right? So first thing we would say is that this is an extrapolation. And then we're going to use our equation to find an x value of 2009. Right? So let me grab my equation. So we had y equals 1.15x minus, and then we had 2,283, and there was some cents to that, right? 55. So 2,283.55. So So I'm going to plug in an x value of 2009, and we'll find y. So we'll find what that y value is. So if I plug this in, right, so I'll just plug this into my calculator, right? So take y equals 1.15 times 2009 minus 2,283.55, and you should get 26.8, right? So this is 26.8. So $26.80 would be the ticket price that we're estimating if this trend continues, right? All right, good. So number 6, try and draw a scatter plot, tell what relationship, if any, exists with the data. Part B, draw a line of best fit for the scatter plot, write the slope intercept form of the equation. Right, so we can certainly do that. Right. So this is number 6. All right, so we have, just real quick, we'll draw the scatter plot, right? So in 2001, 39, so somewhere around here. 2002, well, I guess it's not real. Looks like we skip one, and then so this would be 2002, right? So then we have 2002, 28, maybe around here, right? And then 2003 is 20, so here. 2004, 16, right? Maybe somewhere around here. And 2005, we're at 18, so maybe around here, right? So there's my scatter diagram. Then we want to talk about if there appears to be a relationship, right? So I believe, we're given very few data points, right? So it's hard to draw a definite relationship from this, in the applicable world, right? But for a lot of math problems like this, typically you're only given, like 5, 6, 10 data points. Really, it's not enough, but when you're doing this by hand, it's enough to teach you how to draw a scatter diagram and determine a relationship, right? But typically we'd want a lot more data points than this, right, to draw like definite relationships, right? The more data we have, the more we know, the stronger that our model will be also, right? So yeah, it appears that there's a linear relationship. In fact, it's a downward, right? So like a decreasing linear relationship, right? So you could say that decreasing linear relationship. Right. So then draw a line of best fit and write the slope, the equation of the line, right? So grab my line tool, might draw a line that looks something like maybe something like that, right? Right, might describe our data. So again, I'm looking for 2 points that I could easily guess without, or find the order of pairs without guessing too much, right? So I might pick those two. So we would have, so it'd be, so this would actually line up with what would be like 2000.5. So 2000.5, because it looks like each one we're going up by like half a year, right? So we have 2000.5, comma 50, And then this data point here, right, would be like 2003.5, comma, lines up with 20, right? So I would use these 2 points, right, and come up with the equation of a line. So again, as always, find slope first. So m equals change in y over change in x. So we could do 50 minus 20 all over 2000.5 minus 2003.5. So on the bottom we get what, -3. On the top we get 30. So this would be -10, right? So then we need to come up with the equation of our line. So we have y minus y1 equals m times x minus x1. So I'll just use the 2000, I forgot a 0 here, it looks like 2000.5. So I'll just use this top point. Right? So this would give me y minus 50 equals -10 times x minus 2000.5. So we get y minus 50 equals -10x. This would be plus be 20,000, or excuse me, it'd be 20,005, right? Multiply that by 10, right? Move the decimal point 1 spot to the right. And then we would want to add 50 to both sides. So I would get y equals -10x plus 20,055. Right? So there is the equation of this line in slope-intercept form. Right? And something just to point out is this y-intercept might seem kind of strange to you, right? Because you're looking at this and you're saying, wow, like that's about 50. But something you have to remember is this isn't an x value of 0. This is an x value of 2000.5, right? So this line would keep going, and then we'd have to match it up where x is 0, right? And we're saying that this value is, 20,055, right down the road, right? So just something to point out. One thing you could do is to kind of correct this is you could have your x values be in terms of this year. So you could let x equal the years past 2000.5, and then in that case your b value would be 50, right? So it just depends on what you want your x values in terms of, right? But if we did that, that would change these x values, right? So that would change everything, right? So I left x just to be the year, but you could certainly change other things. So there's part B. So we have that done. All right. So then we're on our last problem. So number 7, you're given average maximum longevity in various animals in captivity, right? So you're given a data chart, do a scatter diagram again, talk about if there's any relationship, draw a line of best fit, find the equation of the line of best fit, C, you're interpreting your slope again, and then part D, predict the maximum longevity for an animal with an average longevity of 33 years. This is an example of extrapolation or interpolation, right? Well, how long? Wow, so I've already done 50 minutes on this video. So actually I think I'm gonna stop this video here and let you do number 7 on your own, right? We've already talked about all of the methods in order to do number 7, right? So I'll let you do number 7 on your own and see if you can come up with the right solution. Because I do have a cap on the number of minutes that I can upload to YouTube. So I'll stop this video here, and then I'll make another video for linear modeling homework number 2, right? And that's using Excel, right? So I hope this has been helpful, and hopefully you can use this idea, this information to help you with the linear modeling project, which is 10% of your grade, right? All right. Well, that's all I have for this video. I'll make one in a bit.